Hi, my name's Andrew Dentler. I chose for my presentation to study the role of physical activity on cognitive development, and more specifically, in most of the studies I looked at, it was adolescents. So mostly elementary schoolers, but some included middle schoolers as well. And I chose this subject because I'm a current health and PE teacher. Um, I also have coached beach volleyball for about 15 years. And I've got two little ones at home and another on the way. So I'm working with kids a lot, and I figured that if I can learn about this subject a little bit more, it'll help me as a teacher, as a father, and as a coach. I want to start out with some definitions. What is cognitive development? And cognitive development refers to the process of how people acquire, process, store, and use knowledge over time. It includes skills like learning, problem solving, memory, language, and reasoning. Cognitive development is a key focus in psychology. Obviously, we've been talking about that a little bit in class, maybe more than a little bit. And specifically with children, like in the studies I looked at, and obviously in our teacher certification program, we are, I believe, K through 12. So children and adolescents. Cognitive development shapes how individuals understand and interact with the world. So obviously in my study, it's how does physical activity impact cognitive development. I also need to define physical activity, and that is any movement of the body that requires energy expenditure. It can include a wide variety of activities like daily tasks like walking, cleaning the house, structured exercises, running, playing basketball, playing a sport. So in finding and reviewing studies on the impact of physical activity on cognitive development, my objective was to review the research on physical activity and how it influences the cognition of adolescents and children. So some of my main sources came from meta-analyses. There's a systematic review in there. So another category that they looked at, they were calling it fluid intelligence and working memory. There was a small increase in that. And again, they have these numbers that quantify the certainty of how much that can be replicated in the real world. That was a low certainty as well. And then they looked for other cognitive functions and academic outcomes. And oddly enough, there was no benefits for attention, inhibitory control, planning, cognitive flexibility, or general academic outcomes. That one surprised me. So the next study I looked at was called Structured Exercise and Executive Function. This study was done in 2016. The children were aged 7 to 12, and this was actually a meta-analysis, so a bunch of studies compiled together. The findings in general, they found exercise programs that lasted more than 1 month improved almost all executive functions. Those executive functions include working memory, cognitive flexibility, and inhibition. And a stronger executive function in this meta-analysis is linked to better problem solving and academic success. Some of the descriptions of their general outcomes were enhanced cognitive performance, which participants who engaged in structured exercise routines showed better performance in executive functions like problem solving and memory tests. They improved attention as well. They observed that exercises helped individuals focus and resist distractions, which is really interesting because I can attest to that in some of my health and PE classes. And then planning and organization, which the previous study I don't think talked about planning or organization at all. But regular physical activity was linked to better planning and organizational skills. And they were able to manage their daily activities more efficiently. So with the lack of numbers and just general data, more specific description of improvements that I was looking for and I couldn't find, I took it upon myself to do a little bit of research that was, I guess you could say, slightly off topic, but very similar. So what I did was I started looking for studies that involved neuroplasticity and cognitive development. And I wanted to look into that because I just had a feeling that there would be a little bit more studying of the brain itself versus just looking at outcomes of improved speech or memory, stuff like that. So I went along and did a little bit more research, and I found a couple studies that involved neuroplasticity, and then gave a little bit more information on looking at the brain and seeing changes within the brain on brain scans and things like that. So the first study that I found was called Neuroplasticity and Cognitive Development. So this study was done in 2020 to define neuroplasticity. It refers to the brain's ability to adapt and reorganize in response to experiences. And normally those experiences are physical activities, are movement-based. And that is, as we know, a key factor in influencing the brain structure and function. Okay, so the 2020 study, training-induced neural plasticity in youth. It was a systematic review of MRI-based studies on neuroplasticity. This one found that physical activity leads to structured brain changes. So they saw increases in gray matter volume and white matter integrity. They found an increased functional connectivity in different brain regions related to memory, and stronger effects were observed in aerobic and coordination-based activities. So that actually ties into, I believe, the second study that I mentioned earlier. Another study from 2020, it was called Neuroplasticity and Cognitive Development in Children. It was a systematic review in response to treatment interventions. This one had 6,000 kids aged 5 to 12, and they found that the brain adaptations occurred in response to the cognitive and motor interventions. They found an increase in working memory, attention, problem solving, and that was all after physical activity. They did regular MRIs on the brain and found increased hippocampal volume in very physically active children. So some of the mechanisms of neuroplasticity included increased blood flow and oxygen in the brain, neurogenesis, I mentioned this earlier, growing of new neurons in the brain, particularly the hippocampus. There was strengthened synaptic connections and enhanced learning and memory. And then, just to generalize, they mentioned, again, the physical activity acts as a natural stimulator to the brain, which we kind of already know. Having health and PE class every other day may not be enough for these kids aged 5 to 12. Just to wrap it up, my conclusion of these studies I looked at, again, I was a little bit frustrated with the lack of numbers. You know, being able to say X% increase in the average of all the kids in the studies for language, mathematics, memory, stuff like that. But I really did like the neuroplasticity studies where they could do MRIs on the brain, see the differences in the gray matter, the neurogenesis, and stuff like that. So I did learn a lot. It kind of confirmed some of my thoughts about physical activity and the cognitive development in youth. I'm probably going to dig a little bit more because I'm a numbers guy, and I would like to see just more numbers, like I said. But being in the positions I'm in, health and PE teacher, longtime beach volleyball coach, and a father of 2, probably 3 here soon, very good to know all this stuff to help me develop the youth in all the positions I'm in, and in the home as well.